decided as we were walking up here that this was such an important topic that we needed an hour and a half, not 45 minutes. So we're just going to blow your schedule. Yeah. So this is not a crowd that we really have to spend a lot of time talking about the changing nature of the grid. But I think that one of the really big characterizations that we often don't focus in on is this convergence of the electricity system, the IT system, and communication systems. And it's that convergence that's going to allow this kind of connected and distributed grid that will, we've got all the IoT-enabled devices. They're not just behind the meter, but they're being deployed on the grid as well. So we're going to explore the implications of that increasing connectivity of the grid, and then also how we might marshal that connected grid to deliver on some societal benefits and create a platform for the consumer choice, for greater reliability, and for cleaner climate solutions. So let me introduce my panel, and I'm going to then let them talk about what their companies are doing in the space. We have Prasanth Gopalakrishnan, the founder and CEO of Kalkitech. We have Prithpal Khajuria, who's the global segment leader in industrial automation, artificial intelligence, and machine learning at Intel. We have Giovanni Polizzi, the Director of Digital Energy Solutions at ACS and at Indra, and then Josh Wong, who's the CEO of Opus One. So let's start with Josh and move down and talk to us. I think it's important for the audience to have a little bit of context for what these panelists are doing in the grid space before we talk about the issues of grid connectivity. So how do you distinguish what you do from other companies working in the grid space?
Yeah, sounds good. Thank you very much for the opportunity to be here. Love the topic around connected and distributed grid, and how we talk about the utility or the grid as a platform. Fundamentally, Opus One Solutions, our mission is really to enable and empower the utility grid as a platform. We believe that the grid has always been a platform. It's only that it has been an electron platform. We have been distributing electrons from supply to demand for the past 100 years or so. But where we're transitioning is for the grid from an assets, poles, and wires electron platform to a data-driven platform that supports two-way power flow to finally a business model and customer enablement platform where we are transacting value as well as something that is also near and dear to GridWise's heart. So what we do is we believe software is the key component to do that, and we actually create a digital twin of the grid in Common Information Model native. So we model the physics of the grid, and we solve the grid in three ways. Number one, to support utilities in their planning exercise, things like DER interconnections, things like dynamic or time series-based hosting capacity, things like understanding the value of DERs for non-wire solutions analysis, etc. Second is on the operational side. So the big buzzword terms, or we like to call it the orchestration layer, which is you bring all these resources. Can I tie in the resources to, let's say, how a utility would dispatch cap banks and load tap changers, and how do we maintain security and resiliency of the grid? Third is around enabling that business model. So now we can plan towards value, and we can operate under constraints. So how do I actively transact value? And this can come in many various ways. So we support actually the animation of markets or creation of new DER programs or support rate design to enable the transactions of value between DERs and consumers and prosumers.
Great, and I hope that we get into the value discussion a little bit. So Giovanni.
Thank you. Thank you for having me. And I couldn't agree more with Josh about the role that software is going to play and is already playing in the grid. The company I work for is Indra, and Indra recently acquired ACS 18 months ago. ACS is a very well-known name in the U.S. They've been producing RTUs and SCADAs and ADMS system with quite a large number. Of course, this is a big investment for Indra, and Indra is a Spanish company, pretty big around the world with more than 43,000 employees, and I personally take care of the digital energy solutions. Indra's got business in different areas. One of them is, of course, IT solutions for the energy. We started some time ago. We've been working in the energy field for more than 35 years with vertical solutions for whether it's generation or distribution or commercialization of energy, asset management. But a few years ago, we started this idea of managing a system of systems. especially for the grid, of course. And we did quite a large effort to create a new architecture that allows us to bring software where software has never been, so basically at the edge of the grid. And with all the number of consequences, of course, in that. It's been a long journey, and then the journey that a few years ago, we also started with Intel, by the way, with the collaboration for the edge component of this. So being able to bring software where very close to the assets allows us to reduce dramatically the latency. So also doing control of the asset, also doing ability to run very powerful algorithm. That's where the artificial intelligence comes along. We also understood that we couldn't do everything alone. So the platform that we created is very open to third parties' application. So we also had to create an environment so where third parties can come and deploy software and help the utility to improve their business. And this span is perfect context. Thank you very much.
Thank you, Giovanni. So this is Prithpal Khajuria from Intel. Everybody knows Intel Inside. So what Intel is doing in the power industry. So we have initiative for the digitalization of the grid. From Intel perspective, working our partner utilities, we see that integration of renewables seamlessly into the grid is very critical. And in order to do that, we need to push intelligence at the edge. In the substations of the future will become like a micro data centers. There will be a software-defined platform, applications will run at the edge, and will control a resource which is running at the speed of light at the edge of the grid. So in order to accomplish that goal, we have to have a couple of things. We need a hardware, which is infrastructure available there in the substation, connectivity to all the assets which are connected along the feeder, get that information, and build a basically analytics at the edge which is going to run and control the grid in a very dynamic fashion. Because what's happening currently, if you see the problem, with the renewable penetration increasing at the edge of the grid, at 1 minute, we have too much renewables coming into the grid, and the next minute, we have renewables disappear, and all the load shifts back to the grid. How do you handle that? Okay, that's called demand generation imbalance, and utilities are facing the challenge all across the world. And we did our initial work in Germany, and we're working with the utilities in Europe, working with the utilities in US, to digitalize the grid. So how it's going to basically look like in future, we'll have an edge infrastructure which is going to run these applications and dynamically control various assets along the feeder. There's no need to go inside the home. We can get a power quality data from the meters and build the analytics. There will be strategically, storage will be located along the feeders. And as Giovanni mentioned, that there will be software component running at the edge. And I think that is the vision we see happening. And Intel is very closely working with our utility partners to develop and prove that what is possible in it. And let various software companies, hardware companies, and system integrators to deliver those solutions to the utilities to complete the full digitalization of the grid.
Thanks. Prasanth.
Okay, thanks, Prithpal. So at Kalkitech, we do plumping of data from the field up to the control center. So like what Prithpal was saying and what Giovanni was saying, we try to connect these systems, the systems at the edge, with the systems at the cloud or the control center. So we have support close to 100 plus protocols. We support close to 1,000 plus devices. And we have been in this industry for 20, 30 years. So we have seen a lot of legacy devices out there, and so we are also up to date with all the new things that's in there. So we can connect these disparate systems. So any digital transformation exercise needs these connectivity. And so we work with Intel, we work with SIs, we work with cloud providers like Amazon and Azure, and try to ensure that there is a seamless pipe between what's there at the edge and what's there at the control center or head end.
So you've all hit on data, and you've all hit on software to some extent, and controls of the grid systems. So when we're talking about data that's being generated both behind the meter and then all the way across the network, can you talk a little bit about the functions where the data can be processed, close to the grid, and what data and functions ought to be processed out in the cloud? So how are you managing all of that data, and where on the grid are you managing it?
Yeah, so kind of architecture which Intel is developing, working with the utilities, I can talk about that. And what we see in our validation, which we did with some of the utilities, is that the data processing is going to happen at the edge. Okay, you have what we call a lot of smart metering infrastructure here. From the smart metering, we can get a power quality data to the substation. We can do a load desegregation. From the load desegregation, we can understand how the PV solar is performing, how storage is being used, how electric vehicles are being charged. And we can basically get inside of that feeder and profile it. Very successfully, it's doable. So that's the kind of one piece of the data. And the second piece is the other assets connected on the feeder. Can be a storage, the rest of the utility assets from reclosures to cap banks. Get all the data from there. And once you have all the data aggregated at the substation, then you can have an application running on the top of it there and take the control decisions. And then becomes a data center or distribution control center or a utilities private cloud. That is where it will become a system of systems, as Giovanni mentioned. And that will look at a macro level. The micro level, the feeder digitalization, all the control decisions are being made locally, but you look at a very higher level. So that is kind of an architecture which we are building, working with the utility partners to basically make the grid ready for large-scale penetration of renewables.
So Josh, you're creating the digital twin. That is all cloud-based.
Not necessarily. It really depends on the application. So when we say what's centralized versus decentralized, we don't think it's an either-or equation. Even all the cloud providers, AWS, Azure, et cetera, is moving to hybrid clouds. For us, it's really to follow the use case. And really, it's the integration across the company resources, whether it's control room integrating with the field, planning integrating with operations, and operational planning, et cetera. So we do see a future of hybridized type of controls, where planning will be able to see the whole system. Operations will have visibility and direct control. That being said, I think it's not just the amount of data, like compared to credit card companies, banks, Amazon, et cetera. This is not a big data play in our industry yet, but it's certainly a big computational play, because the computational horsepower that's required to solve this grid, as we know from the physics or the engineers in the room, is more complicated and more computationally intensive than many other industries. And so we believe in actually computational decentralization, where control room can have their own set of controls, but also back to Prithpal's point, which is the substation, let's say, can also run a mini version of localized grid control, then furthering to go down. How we respond to it is data's data, computing power is computing power. So when we architected our solutions of, let's say, Kubernetes, Dockerization, containerization, et cetera, we run the same analytics software inside the control room as an on-prem solution, on the cloud as the hosted for big, like computationally intensive full system analysis, such as like hourly hosting capacity for the next 5 years, 8760. That's a lot of computational horsepower that's required. And then in fast responses in real time, let's say in a microgrid setting for resiliency or for dynamic ramping up and down on batteries, we can bring the full control capabilities of an ADMS or ADMS Plus into a substation local level for fast reactions. So we think it's an integration and coordination based on the use cases that's required.
Prasanth, you were going to add something?
I just want to add to what Prithpal was saying is, I think the use cases will evolve, right? You have data sources always in the field, sensors, you have those stuff generating data, and the data moves up to the cloud. But I think as we see how the networks evolve, like your cell phone, right? You have your static phone, and it moved to cell phone, then the apps moved to your phone, but the data is still on the cloud. So the user is doing everything on his phone, but the data still resides. So you have a semblance of an idea that everything is happening on your phone, but pretty much most of the things is happening out there on the cloud. So the grid can also kind of move into such a scenario where in which you have a lot of data and control happening at the edge, but maybe a lot of data still resides in the cloud. And so how much data resides where, and how much use cases is in the field versus how much use cases is in between in a substation versus how much is in the cloud, I think it will transform as customers and technologies evolve, is what I think.
Giovanni, did you want to add something?
It's for us, it's more a topic of latency. So how fast things have to happen, and so of course, the closer we go to the assets of the grid, the faster we can be, and also the more autonomous they can be, because in case of loss of communication, then you don't need to go back and forth to the cloud. Of course, you can't run everything locally because you would need a lot of processing power. Sometimes doesn't make sense on some of the assets that you're connected. So you don't want to put something that's more expensive than the asset itself. But the latency is one of the problem. And also, being very close to the assets allows us to deploy a software which is very specific of every single asset. Without any, and if this, especially today, that the technology is not yet clear. So there's a lot of new technology, storage and solar, of course, being the main. But there is still a very consolidated standard in the market. So things will change, and if utility today wants to have a long-term vision, a long-term possibility to change, then it has to be very close to the asset and deploy the solution that actually works for that particular asset and also for that particular configuration of everything there is around the asset. So in that case, rather than make it very complex in the cloud, we can make it much more simpler. I like to speak about clusters of automations and clusters of healing, let's say, clusters of self-healing part of the network, which can be done basically by going down at the edge of the network.
And so if I could ask about artificial intelligence and the potential of artificial intelligence overlaying on the data to help with the healing, the self-healing, and to provide insights and better optimization for grid functions. I know, Prithpal, you've been working in artificial intelligence.
So I think it goes to the foundation which Giovanni and Prasanth and Josh said. First, there's two parts of it. Some people say, do we need infrastructure first or we need applications first? So I think the way our work with Southern California Edison, they got recently a DOE award for the innovation. The utility think that, okay, I need to build the infrastructure first. So I have a compute infrastructure in the substation first. Then the applications, as Prasanth mentioned, has evolved. The applications will come. But know what was happening, we have all the data aggregated at one location at the edge. That comes to your next question about the AI. What we're seeing that there is the emergence of it, that we move away from current, what we call a rule-based control system. You know, that's what the whole SCADA is. A and B happens to the C, okay? So from there to a autonomous control systems which are learning and optimizing and improving performance over time. And I think that is where we see the AI coming at that level, at the edge. And then basically what data makes sense to take it to the cloud and then do a higher level learning there. So I think that's a kind of a way we see it is going to evolve. And I think the next step is, I think bigger thing is that protection and control, okay? And that is where you'll have a similar infrastructure, which we are right now in a substation, we have 50 to 100 different protection relays sitting there. How we can converge those protection relays into a single infrastructure, and that's where the artificial intelligence technologies will come and find those faults which we don't see currently and optimize the infrastructure and improve what's we call it a reliability, safety, and security of the grid.
Josh,
Yeah, absolutely. I think this world has to move towards, from a rules-based world or protection-based, or worst-case scenario, rules-based, everything can break, like all hell can break loose, to an optimized world where you put a battery there, but what do you do with the battery? If you don't know what to do with the battery, it's just a sitting loss. Or if the battery simply follows a KISO signal, for example, then the distribution companies may not be really in the loop and cannot be optimized. So I think that this brings us to the world of optimization. And just maybe from a very high level, there are two different worlds of optimization in our space. One is the traditional operational research. So for the engineers in the room, like an optimal power flow that is physics-based in optimizing volt VAR and conservative voltage reduction, et cetera. The other is the AI world. I think if we call ourselves an AI company, we can make a lot more investment money, but we'll have a much harder time selling to utilities, because how we reconcile, and it's two sides of the pendulum as well. So how do we balance both sides? I think the most sophisticated side of our integrated infrastructure, for example, the bulk power signal, came from the OR space, the operational research space. ISO markets, LMP pricing, that's all driven by optimization of the power flow based on the model of physics of the grid. VVO applications, that's based on that as well. AI definitely offers potential, but currently there's actually not a lot of data sets within the distribution grid to offer AI apart. I'm talking mostly above the meter, not behind the meter, optimizing the decentralized grid rather than individual homes. So I think there's going to be a convergence of pendulum swing between those two, where the physics-based world and the data-driven machine learning world will converge. I think it's going to converge first in a form of more of forecasting, combined with basically future planning of grid scenarios and impacts to the grid, and optimization of DER dispatch.
Giovanni?
Well, I agree with the
What he said.
No, but in the sense, that there's a lot of potential of AI. What is needed is the data. Even though there is a lot of data, there isn't still that much data to go a step beyond what is the standard protection and control of the standard models. We can digitize much more today, but of course we can't really push. And there's a learning curve, and we don't yet know exactly what all we can do with AI. We're learning fast.
Just to add, I think AI adoption in real-time systems in a substation, I think it's still some time away. So you still have legacy infrastructure, you still have the physics like Josh was saying. I mean, all that, just moving to a data-driven AI-based algorithm, I think it'll take some more time, maybe more research, more data, and more applications. But what will still happen is adoption in terms of things that utilities right now see use cases, right? If preventive maintenance, predictive maintenance, asset life. So there are a lot of use cases where AI we'll see initially, but will AI run a modern network? Maybe it's some more time away, I think. But when you have islanded grids with renewables, and if you can just look at that small power flow and can you run it with that, maybe that's where it'll come if it comes.
So if I were a utility and I were coming to you to ask you for your advice because I'm about to put together an integrated resource plan to bring to my Public Utility Commission, and I'm looking at making 20-year investments now because my rate case is this year, what would you tell them are the one or two technologies or softwares that are available right now, but that will help set the stage for this 20-year investment that allows the system to evolve as new things happen. So
Karen, I'd like to add here that basically here's the approach which Intel took discussing with the utilities around the world. I think I spoke with probably close to 50 to 60 utilities around the world. We basically, what is the problem? We'll start from there. The first bigger problem utilities are saying that predicting or forecasting demand and generation correctly in the environment where renewables are behaving so fast, the demand and generation imbalance, which is affecting the utilities, because too much renewable, loss of revenue for the utilities, and excess generation sitting in their hands. That's the problem they are facing. The next thing is the dynamic overloading of the grid. 1 minute, you have too much renewables coming in, they are overloading the grid. Next minute, they disappear, all the load shifts back to the grid, and grid has to provide the power, okay? Then the next thing is that instabilities which come with that. Your voltage is fluctuating, your frequency is fluctuating. And the last one is, which Prasanth touched on it, basically stress on the equipment and predictive maintenance and failure. So these are the 4 use cases. And when we work with the utilities, okay, we define the problem. So what is the best way to solve the problem now? You can buy basically, which they have been doing for last 50 years, a fixed feature function solution, put it there in a substation and do that today, and we'll worry about tomorrow. What's happening because of that, they have so many applications sitting in the substation, probably 25, 30 of them. They have so many back-end systems running that integrating all of them is another big challenge. How can you think about a flexible, open architecture? And I think that's what we are suggesting to you, working with in partnership with the utilities, to build a modern infrastructure which is flexible, and then it can, as your need for applications grow, they can add more applications. And then that will move to the next level of using artificial intelligence.
Prasanth?
So, if I have unlimited budget or the utility has, the best thing is to collect data, right? So you invest as much sensors, equipment, instruments that you can invest in, and collect as much data as you can. So the moment you collect data, future technologies will evolve, right? A cloud or a AI. So AI will not work without data. So as much as possible, the next 20 years, if you to protect those investments in the future, put sensors, put equipments, and collect and store that data. And then you can reuse that data to do anything else you want in the future. Even if you don't have, you don't know the technology that is, maybe there's no technology right now to use that data right now, but still, if you collect it, that would really help future R&D, it'll help future applications. So I would always say that in addition to what you know of, whatever stuff that you can put there in the network that can collect data will help.
Giovanni?
I would advise, you said 2 recommendations. I would give 1 at least.
Or 3.
One is invest in interoperability, and let me expand on this. A problem that today utilities have is the lack of interoperability among protocols, hardware normally, and when you get to software is the interfaces among systems which weren't built to be communicating. And so we don't want to be in 10 years having very modern technology and having created the next legacy very modern technology. All these new brilliant AI systems which do not communicate among them, which are perfectly to run their function they were born for, but are not able to expand. So when I say invest in interoperability, I mean invest in a platform, and this is very, very close to what Prithpal was saying. You need to create a software, an architecture, infrastructure that allows you in the future to put all the data together without being bound to the system that is collecting the data today. We were talking to a utility a few weeks ago, and they were saying we collect data from every substation. 95% of our data, we don't use it. We don't even know. And the guys that need it say, no, because this is the guys from the IT that have the data. So we are used to have a system that collects data and develops vertically all the intelligence on that system. We got to break this, because otherwise we'll have this very modern application, again, a new silos. So that's the platform that I would tell a company invest in.
I certainly agree with the platform approach. If there's anything I would like to invest in is the platform approach as well, and that's consistent with the theme of this meeting too. But let me take a step back, right? I think for a number of us, myself included, this has been maybe 12th, 15th year of working in the smart grid space. one of the early analogies is coming into the smart grid space is like going to a candy store. You have all the candies in the world, and you got to invest in which candy. So we have, I think, all the candies around DERs and storage with electric vehicles, sensor technologies, comms networks, automation systems, security systems. All of those are getting more and more mature, and quite mature as well. Some of them getting commoditized too. I think since the context of the question is on investments, I think right now what we need the most is an investment decision-making framework. And that is also one of the biggest regulatory challenges the industry is facing, which is non-wired solutions, right? One of the candies is still poles and wires and copper and oil, but what helps us decide and prioritize these from traditional investments to a lot of new tool sets and knobs and levers that we can have, and how do we provide a case that is defensible, reliable, repeatable, traceable, and scalable. Right now, let's say with a lot of our non-wire solutions decision-making framework, it's fairly ad hoc and it's fairly locational specific. But for example, can we scale that across the system? Can we scale that so that every single one of our investment plans is subject to various decision-making criteria? I think that's investing in the investments is my topic.
And that brings me to the next question, which is about capitalization and where the barriers might be as you start to move away from the sensor to the platform. And so maybe you could talk a little bit about how the new technologies versus the data processing creates challenges to existing rules and conventional models of capitalization. So, and maybe how that's being experienced not just by different investors, but also in different states. So I don't know, you want to start here, Josh, and we'll just walk all the way down?
Sure, I think we all have strong feelings about that. But I think it's an age-old problem around capitalization of software, especially hosted or recurring ARR type of software. And I think I think two sides, right? One is, as a company ourselves, we are responsible for our own shareholders and our own investors, and everyone's trying to get that AR model, which is more of an OpEx. So I know even I think last week there was another PwC webinar that goes on around, and it's still a challenge on capitalizing software. However, so the supplier's angle and keeping the supply economics working is one key thing. But the other is the sheer use case, because software is so fast, so rapid, so agile, and the problems that we expect software to solve is also growing on a weekly, even daily basis. So investing into traditional CapEx, capitalizable license models, it's actually a risk. It's actually a risk because that software is likely going to have to change and adapt within the year of its investments, subject to various customer requests or regulatory rules or grid dynamics. So how do we increase the clock speed or the agility of this industry as reflected by investments on how the utilities can make money, and also how the suppliers can also remain healthy to supply that in an agile way? I think it's a problem that we need to solve together.
Giovanni.
Yeah. Yesterday I was listening to one of the intervention. I think Susanna was saying that there is a utility will be the place where others basically provide services. The value of software changes with the services you can provide on. It's very difficult to capitalize today when you're thinking in the next 2 years you're going to have a number of companies that are providing services on top of that software. The PUC of Ohio, I think, produced a recommendation called Power Forward. And they actually say, you got to make the data available to everyone, because everyone can provide services on that data. And data means your customer data, your operational data, your asset data, because so a new service will increase constantly the value of that platform. And it's very difficult today to say how much is worth for the next 5 years. Very difficult. Total different way of evaluating the software. Yeah.
Yeah, Karen, so I think my discussion with the utilities, I see that there's two kind of costs for the utilities. operational cost and capital cost. First thing is how to collapse these costs. I think the challenge has been this approach of buying one application for one problem. If you go inside their infrastructure, let's say talk about the substations, you have automation and control, 20 applications. Can we build a rugged infrastructure to collapse? My discussion and data with the utilities, which says there is a 70 to 90% reduction in operational cost. Once you consolidate that infrastructure, in Intel terms, put a stack of rugged servers, virtualize just like data center. You reduce your operational cost by 70 to 90%. Now talk about the capital cost. That goes down too. The other biggest problem utilities are facing, again, these silos applications running in their data centers. I think those needs to be collapsed to a modern platform approach. You don't need a ADMS, OMS, asset management, ASRI, the GUI, the 10 application. You don't need all this stuff. So what do? You collapse that, you bring your capital investment down, okay, your integration cost down, and I think that is the thing utilities have to look in, because the grid is evolving so fast, it will become a grid of microgrids, okay? And that is, I think, way you to bring the capital cost down, operational cost down, and move forward.
Yeah, I agree with what everyone was saying. I think unless the utilities start considering SaaS services or cloud services or recurring services as capital, they have it's very difficult to make them buy or put them in the budget, right? So, and I think that's a big impediment to a lot of purchasing that we see. And it could also be linked to how the regulated utilities are incentivized, right? They get return on capital. So I think unless the whole structure changes, at least from a capitalization standpoint, they can buy software as a service or something, I think, and either put in a capital bucket or increase their operational budget for these services. I think,
there isn't one answer to this question. There isn't an answer to the question necessarily, and I think that's one of the reasons that GridWise, and not all of you were here yesterday, but Steve and others laid out kind of themes going forward for the next year, looking at this issue of technological obsolescence and the policy and technological tools to address that, and also then what flows from that are the CapEx and the OpEx solutions and how you work with regulators to kind of create more flexibility. So, stay tuned, because I think that's something that GridWise is going to be spending a lot of time talking about over the next year, and hopefully producing some materials that'll help inform what ultimately is, you got to work with the regulators to get them to understand the need for new solutions. So I want to shift just a little bit, because we've mentioned value of the investments. I want to talk a little bit about the value that the data can provide, the insights into the value of resources on the grid. And most of those conversations have been around time value, the value of resources coming on and off the grid at different times of the day, or seasonality. But I want to talk a little bit about locational value, because I think that as we grow the distributed nature of the grid, one distributed resource is not necessarily as valuable as another distributed resource, depending on not just when it comes online, but where it is in the system. So can you talk a little bit about that issue of the different value of distributed resources around the grid, and how the new data and architecture are allowing us potentially to further define that value? And also maybe a little bit, my concern is that once we actually can do that with great clarity, we are going to have to explain to the customers why your solar panel is not nearly as valuable and should not be compensated nearly as much as potentially another solar panel that your neighbor might have on the other feeder. So if you talk, let's start with Prasanth at the other end. If you want to talk about valuing distributed resources. And
yeah. To me, I think it's a complex subject to say that, okay,
we can talk in 5 minutes, you can solve it.
So the problem is that value keeps changing as well, yeah. Right? So if you put a DR or a renewable in one location, and then you have a need to put it somewhere else, and then one more comes up, then the whole value changes. right? So the value is not static as well. So that's where all the static models that we do in our ADMS and everything has some concerns. And in terms of really predicting, all your models you have to redo the models every time. And it's not easy to go back to the customer and say that, okay, your value is this, but okay, after 1 year, the value changes. So to me, I think that topic is complex, and I think technology has to evolve before you can kind of educate the customer, say that your value is changing because of this, and it might change again in the future because of this. So I think, to me, it's an important subject, but might be somewhere further down the line.
Next year, not 2020, 21's grid-wise
So
theme.
Karen, we'll look at the different perspective. I say the value, let's look at value from the utility perspective as a part of the grid reliability. Okay? So if you go from that perspective, everybody puts renewables, everybody's happy, but when the sun goes away, the clouds come, they go back to the grid, ask hey, provide me the power. If you look from value from that perspective, I think that's where the things change will. The utilities or whoever needs to very strategically, they have to put storage into the grid. Okay? When you have too much renewable coming, you go charge those batteries. And when you're basically clouds come and the renewable drops, you have that value stored there. And I think that is what I connected to the reliability of the grid and how to connect value to it and increase that. And I think that is what is going to drive the investment in the modernization and digitalization of the feeders. And then each grid feeder we'll see is going to become like a microgrid. And when that happens, in that, then basically the value of each customer can be, I think it becomes tangible at the time, if sun is shining, how much you are producing and feeding back to the feeder. And I think that will drive those equations, maybe new business models, new trading models. So I think there's a lot of innovation will happen in that, and that will define the value.
Giovanni?
Yeah. We are used to evaluate the energy of the assets. Of course, value is going to become the energy, the power, the apparent power, which is a nice concept to tell someone they actually are paying for apparent power. And the location, very, very critical because of course, everything is connected to infrastructure. If we are thinking about non-wire solutions, then there are in different parts of the network, the asset costs more or less because you have to go across a mountain or you have to go around an area. You can basically avoid that. So even the location is very important. The location is also important because of the climate. How fast do the clouds normally arrive over there? We were talking to another utility, and they would call it they call it a 20 megawatt cloud because it basically arrives, and they know that in 10 minutes they're going to lose 20 megawatts because of the. And so, how much is all those panels? How much are all those panels worth? But 20 megawatts of ramp up and ramp down very, very fast. That value is something that can be, thanks to AI, can be actually forecasted and can be put out in this famous platform of services. So there's a very nice example in Australia. I was living in Australia before coming here, and in all the utilities actually providing in an open platform the information on in the area which are congested because of a high penetration of rooftop solar. And so they actually give a price to each area. So if someone wants to do an investment in other things and not a normal wire solution, that's the value the utility is available to pay. And it's open, so all investors can basically look and say, okay, here in this substation, I can put a battery, I can put a solar panel, I can put some other ways of DR to basically displace the cost of doing investment. That's a static value. Then there's the dynamic value that I was telling before. So the power and the rapidity with which a distributed energy resource can interact with the variable conditions of the network.
We do have 45 more minutes, right?
Yeah, that's right. And we are going to have time for questions.
Okay, so we at Opus One, we have been working or wrestling with the value of energy for 4 years now, since the early days of REV. Our National Grid DSP project, so the Distributed System Platform project, has been completed last month, and where we create actually locational and temporal value of energy by distribution node, if you want by phase, every single 5 minutes to an hour, day ahead and same day. So we actually opened up a market on a pure transactive basis where you're providing locational and marginal, locational and temporal and stackable value of energy that you can offer to the customers or prosumers to bid on. We just finished another project with Amaranth on gamification. So we actually allowed them to gamify what a locational and temporal market may look like. The objective is to surface the value so that we can have quality business policy and regulatory discussions. We're not necessarily advocating or requiring a certain market construct or market design, but here's the value, here's the physics. It's same as the ISOs, right? Here's the optimal power flow, here's the marginal cost of electricity. Can we have a quality discussion around how that can be translated into new customer models and business models? We have another project with the Ontario IESO, a multi-million-dollar project involving 3 distribution utilities to look at the LMP, ISO LMP to distribution, locational pricing approach. And we have another project kicking off soon with 10,000 DERs where we're providing same day and day ahead value of DER actually using a DLMP calculation. So you'll see in next Distributech in a month or so where we will actually showcase a true distribution locational marginal pricing calculator that takes your 3-phase AC unbalanced model of the grid, and you can calculate your DLMP costs, which includes your energy costs, loss factors, as well as your congestion charges. Is that it? Probably not. I think we're just surfacing the math. It's like us, a whole bunch of econ and engineering geeks surfacing the math, and computationally it wasn't capable before that, but now it's capable. So let's talk. Let's talk about, are these going to translate into a new non-wire solutions type of metric, or a new DL program like a demand response program, or is this going to go full-blown into a distribution level locational and temporal market? I think would love to explore where this takes us.
Yeah. Well, so explore we will. So I want to leave a little bit time for questions. So I will thank the panelists. Very little. One question? Hey, I still have time. I have 2.5.
No, it's cutting up.
Oh, we've gone over. Oh.
Ah,
Well,
okay.
so we have
45 more
43
minutes.
minutes. We have 43 minutes.
There's a question right here. We'll take that question now. Go ahead.
Right. I think this is a question to Prithpal. You gave good insights about existing SCADA systems, local automation and control. Unless we bring the data from the substation to the cloud and digitize it, and first of all, modeling your substation itself is a challenge unless we have the data set, right? How much percentage of this sort of maturity is in the market right now? Are we in the right trend? I mean, utilities are really forwarding in the right trend. If it is so, how much of percentage of progress we made in the market?
Okay, so let me answer your question. So the idea of digitalizing the substations in our Intel perspective discussion with the utilities, at least 10 to 15 utilities, big utilities here in US, everybody agrees that they need to digitalize the substations, they need to digitalize the feeders. Okay, but at what pace that will happen, that will basically drive some of the regulatory initiatives, how the regulators approve the rate case. The most disruptive utilities, Southern California Edison and Hydro-Quebec in Canada. Southern California Edison proved that architecture of micro data center, building in the substation, working with Intel, and they're going to say the next year they're going to start deploying into their transmission substations. I think sometime next year, I think that's what it is. And they got a rate case, I think, approved from the regulators, public information. Hydro-Quebec, on the other side, also issued a RFP for basically digitalizing all their substations. And they have already awarded that hardware order to one of the vendors. Okay, so they are moving. So these are the two, you can call the lighthouse customers. They see the value of digitalizing their substations. But there are many utilities, they are all planning in that way, and they all feel that they have to digitalize and collapse the hardware in the substation, both automation and protection and control. So Intel is working on the protection and control side. We're going to demonstrate at Distributech a first virtualized protection and control system. And if anybody of you coming to San Antonio, come to that, see that solution.
Thank you.
Welcome.